So far, we've only discussed systems of linear equations, because linear equations have a big advantage. That advantage is that their graphs are straight lines. The reason that that gives us a big advantage is that when two straight lines intersect, they only intersect once. Or occasionally we have parallel lines, in which case they intersect not at all. When we have nonlinear equations, their graphs are curved. That's why they're nonlinear. And that presents some difficulties. For example, consider this system. Right, equation 1 we recognize as the equation of a circle. And equation 2 we recognize as the equation of a parabola. We see those graphed here. Here's equation 1, and here's equation 2. And we see that these two curves intersect at 4 different points. Those 4 points, we've got -2, 1. We've got -1, -2. We've got 2, 1, and we've got 1, -2. Right, those are the 4 points where those two curves intersect. And we see that all of those points, if we plug them into our equations, so in equation 1 we've got -2 squared plus 1 squared really equals 5. And equation 2, we have 1 equals -2 squared minus 3. Those are both true. That's really a solution to our system. For the second point, in equation 1 we have -1 squared plus -2 squared equals 5. Again, that's true. And in equation 2 we have -2 equals -1 squared minus 3. That's also true. That's really a solution to the system. We can plug in the other 2 points, we'll see the same thing. 2 squared plus 1 squared really equals 5, and 1 really equals 2 squared minus 3. 1 squared plus -2 squared really equals 5, and -2 really equals 1 squared minus 3. All 4 of those points really are solutions to the system. They really do work in all 4 equations. So whatever process we have for solving that system, it's going to have to give us all 4 of those points. There's something else that can also go wrong with the system of nonlinear equations. In this example, we have 2 equations that are both equations of circles. This one is centered at 0, 0, so this must be equation 2. And then this one is centered at 1, 1, so this must be equation 1. And looking at these, I mean, I don't think that we could call these parallel in any meaningful way, but they never intersect. This system has no solution. So whatever process we have for solving a system of nonlinear equations, if we throw it into this, it's going to give us no solution in some sort of way. So these are all things that can go wrong with nonlinear systems. We might have no solution because the curves go around each other. We might have a whole bunch of solutions because the curves go back and forth and cross each other more than once. And then when we go to solve nonlinear systems, all the complications that might come up when we go about solving a nonlinear equation in one variable, they still happen when we're solving a nonlinear equation in 2 variables. This is especially difficult if we want to solve one of our equations for y or something like that. So we'll see all of those complications. So we see all of these complications when we go to solve a system of nonlinear equations in 2 variables, but ultimately, we don't need anything we don't already know. The techniques that we use to solve linear systems generalize to solve nonlinear systems fairly well. All of the complications that come up based on the fact that these are nonlinear systems have already come up for us working with single nonlinear equations. So really, we're just combining a bunch of skills that we already have to solve this new kind of problem.